that will be enzyme catalysis. The effect of concentration on the catalyst and the effect of temperature and pH on the catalysis process. Now, what is catalyst and what is catalysis process? For a reaction to happen, that is to get from reactant to product, we can fasten out this reaction by heating it up. So the reactants will get higher in energy and produce the product in a faster rate. But also it can be done by the help of a substance named catalyst, just like in human body. So in human body, catalyst would be the enzymes that get secreted. And the whole process of this is called the catalysis process. So without using excess heat, human body works pretty much using catalyst, most of the metabolic reactions. So how this works, let's look at this graph. So in a reaction pathway, you can see the energy that the reactants have, and to get to the product, the reactants have to cross an activation energy barrier, which is quite high. Now, using catalyst or enzyme, we can lower that activation energy barrier. So, getting to reactant to product, it will get much faster, and we don't have to use that much energy, right, Ms. White?
Right. So what you see here is the activation energy barrier is lower, so the reactants don't have to rise as much in energy to go over. Okay, so the yeast is the one that provides the catalyst, right?
Exactly. Catalyst named Catylase enzyme. So catalase enzyme. So we can use this catalase enzyme to actually decompose this chemical substance, naming hydrogen peroxide. Now, hydrogen peroxide is a byproduct of the metabolic process that happens in our body. It's quite toxic. So what catalase does is just break this down to water and oxygen. Now, using the catalase, what will happen is this catalysis environment, our human body is in a perfect environment. What we're trying to do here is that do the same reaction when the yeast gives us the catalase enzyme by changing the conditions of the environment, concentration, temperature, pH, how that affects the decomposition, this decomposition reaction rate. So that is the goal of this lab.
So what we're going to be doing, as she said, is that if the catalase concentration is increased or decreased, will the reaction go faster or slower? And like she mentioned, you have an optimum environment in which the catalyst will work, which is in your body. So in your body, you have a set temperature around 37 degrees Celsius. And so we're trying to see, when we are at 37 degrees, is it going to go faster or slower? What if we go colder or warmer? How will that affect the catalyst? And then the pH. Your body is slightly basic, slightly above 7, so around 7.4 pH. So what if we change it and make it more basic or more acidic? Will that affect the catalyst, and will that make the reaction faster or slower? So we're testing all of this in the reaction. Thank you.
Thank you. Okay, now for this enzyme catalysis lab, what are the things we need? So I have prepped some of the things. So first of all, we need the yeast. Already yeast solution has been made. The catalase enzyme, we'll get it from the yeast solution. Make sure when you are doing the lab, make sure the temperature is at optimum of like 35 degrees Celsius. So we have medicine cups labeled as 100% catalase, the yeast solution. We have the hydrogen peroxide, our reactant. All the pipettes labeled. And we have the well plate also labeled for the first one. Now, cutting the filter paper. What's the purpose of the filter paper here? We're gonna cut the filter paper in such a way that we can take like a small square of this filter paper like this, dip it on the catalase solution, and then bring it over to the hydrogen peroxide. So to cut the filter paper, make sure to take the filter paper from your kit, fold it in half, another half, and cut it in so small squares, 7 millimeter by 7 millimeter. Try to be consistent with the size of the squares. So to begin with, we're gonna take different concentration of catalase into this wheel plate. So what we will need is, first of all, you should take a look at page 8 for the activity 1. Make sure to follow the table to keep a consistent concentration of the catalase. So first of all, we're gonna take the water. So on 0% concentration, that means there's no catalyst. We're gonna take 20 drops, just the water. Then the second one would be 25%. So I'm going to do that. 15 drops of water. Then, and just 5 drops of catalase. Let me first get done with the water part. So 10 drop, 50% would be 50, so 10 drop of water. And the last one would be no water added. So you see here, to keep the catalase, the 100% catalase at a certain temperature, we're trying to maintain the temperature by keeping it in a water bath, warm water bath. So now I'm going to start adding the catalase. So 0% concentration, there's no catalase to it. And the 100% would be all catalase. So the 100%, let me start with that, 20 drops. That's all catalase. Let's go to 75%. That would be 15 drops. 50-50 would be, I already have 10 drops of water. 20 drops of water here, so 10 drops of catalase. There you go, 10. And 25% would be 5 drops. There you go. Done. Adding. Now what we are going to do, we're going to, using the forceps, take one of the filter paper, one by one. So here's the H2O2, dip it, there, take it out, and see that, can you start like, okay, so I'm gonna push it and keep it at the bottom of that, and we're gonna start the timer. Is it coming up or not? How much time does it take to come up?
When it gets to 3 minutes, if it hasn't moved,
Mm-hmm.
stop the timer.
Yes.
The reaction is over.
So the idea is if there's catalase on the filter paper, that will facilitate the decomposition of H2O2. H2O2 breaking down, it produces oxygen gas. So the oxygen gas will make the filter paper float to the top surface. Let's try with the 25%, where we have 25% of solution. So let's take one piece of the filter paper, dip it, and then is white ready, and let me push it at the bottom, and let's see how much time does it take. Okay, there you see. So we can stop the timer. What else we need? We need the distance that it traveled. So we need the ruler for that. And record the distance. From to the bottom to the top. So how much we can say? Not much.
Yeah, okay, put it on this side. 2 centimeters?
About 2 centimeters. Out.
And don't forget to record your time in the data table 1.
Yes. So let's do for 50%, same way. So reset, right?
Yeah, and make sure you don't use the same filter paper or filter disc.
Mm-hmm. So in between trials, make sure, sometimes to soil the well plate to keep all of it good mixed.
How will we maintain that?
So 50%.
So the height should be the same, right? The distance?
Yes.
We don't have to remeasure it.
No. So as we've measured it already, let's try with the 75%. 75%, start. See, the higher the concentration, faster it comes. So I just waited for it to. There you go. Make sure to record your data. Time. It's 100%. Should be the fastest one. So let me push it at the bottom and start. So you can see higher the catalyst concentration, faster is the decomposition and much less time. So the idea is that with the time and the same distance, by changing the concentration, how it's affecting the reaction rate. So the distance divided by time should give us the rate. So to see the change in temperature, how it affects this reaction that the catalase is decomposing the H2O, what first I want you to do, guys, is keep the hydrogen peroxide and the 100% catalase freshly prepared at room temperature. For us, the room temperature today is 25 degrees Celsius. So with a 100% catalase, let's take 20. I've taken 20 drops of it. You see that I've labeled that I'm labeling the second row for this temperature. The first row was for the concentration. So this is 25 degrees Celsius temperature, the room temperature one. First, let's do this one. Then we can change the temperature. it might be cooler than this or warmer than the 25 degrees Celsius one. So with the room temperature one, let me first do this. Take one filter disc, load it up in the 25 degrees Celsius temperature one, and then let me put it at the bottom of the hydrogen peroxide and start. So let's see how much time it takes for the produced oxygen gas to push the filter paper up at the surface, and we are done. So 16 seconds for the room temperature catalase. Now we're gonna change the temperature by adding ice or using hot water and see how that affects this reaction rate.
So for the ice, the peroxide is placed in this makeshift bath we made. We cut a styrofoam cup. I hope you can see that. We cut a styrofoam cup so that we can actually cool the peroxide without tipping it over. We didn't want to place it in here. We didn't want to have it tip over. So this is our makeshift bath.
Okay, so I'm gonna see the temperature of it.
Okay.
Let me wipe it.
We want to keep it around 15 degrees. If it's not that cold, then we want to wait a little longer. So trying to measure the temperature.
Yes, it's much lower than that. So it is around actually 10 degrees Celsius.
Okay.
So this should work.
Now that one is ready. We make sure you measure the solution so we know what's
also
going
that
on.
too.
No, in the solution.
Let me wipe that off.
Because that one has been there longer.
Yeah, this is also around 10 degrees Celsius.
Okay. Who's ready fast?
So this is ready. Let me take 20 drops of catalase from right here.
Now the lab says make sure you record the actual temperature, not what you wrote down. We're trying to get the actual temperature. So whatever you measure here.
So for us, I have written down as 15, should be corrected like 10 degrees. So at least 10 degrees below the room temperature, so 20 drops.
If you can, please make sure these are in the same bath because that way you have the same temperature. If you can't, then do what we did and try to get them very close together in temperature.
There you go. Got it. Let's keep there. Now let's do this again. Take one filter paper, disc, soak it right there. I'm ready with my stopwatch. Let me push it at the bottom of the hydrogen peroxide solution and start. Let's see at much cooler temperature how it affects. There you go, done.
To get the water, the warm water in the desired temperature, we got some hot water here, and we're gonna pour it into room temperature water and keep adjusting it until we get it close to the temperature. So we're working on 35 degrees now, right? Okay.
This is much lower than that, so we're gonna add a little bit more hot water.
Okay. It's hot.
Okay, there you go.
Okay, so wait for a little while and see. Let me get it hotter than that. Okay, this is close to 35. Not at 35 yet.
So for warmer water at least 10 degrees above the room temperature, let's take the catalase, same way.
1 minute, let's make sure the temperature, it should be warm, right?
Again, 20 drops.
Yeah, wait a little longer on the peroxide. Okay, I need to get this water even hotter.
So we have the 35 degrees Celsius temperature catalase. We're going to take one of the filtered disc, load it here. I have the timer ready. Let me push it at the bottom of the cup and start. See now with warmer water how it changes. So the same way, the way we prepared this water bath, keeping the temperature same for the catalase and the hydrogen peroxide, keep doing that at least 20 degrees above and 30 degrees above the room temperature. So this is the part where how temperature affects the decomposition of hydrogen peroxide. So the third part of this lab would be changing the pH. So first of all, changing the pH. So we're going to first do with acid solution. How to see the effect of that? First of all, let's make a different concentration of acid solution. So on the well plate, you can see the well plate is labeled already as A1, A2, B1, B2. So A would be the row and 1 would be column. So first of all, let's take for A1, let me take 20 drops of just hydrochloric acid.
And we are on direction number 6 on page 11.
So with just the 100% concentrated HCl, we're going to start the serial dilution now. Taking, first of all, keeping the concentration same, 10 drop. So this will be A row would be our stock solution. Let's take 10 drop from it into B1. That's done. And 2 drop of this concentrated to A2. Now let's dilute this A2. So I'm going to dilute this. The stock solution should be of 20 drops total of. So I've done 2 drops of acid. Let's add 18 drops of water. There you go. And let's take the acid solution from this A2 well. This is stock solution. Let's take 10 drop here. And let's take 2 drops on A3. So let's dilute third time. Eighteen drops again. There you go. And let's take this stock solution. Take 10 drops from it. And let's put 2 drops more.
go. You see what I'm doing? I'm going to do it twice more. So stock solution. There you go. Then this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 drops here. 1, 2. Let me dilute it. There you go. And finally, taking this last solution, 10 drops of it here. There you go. Okay. So, all serially diluted, the acid solution. Now, let's add the catalase to this. So, for each well, I'm going to add 10 drops of catalase to the B row. Remember, A row is the stock solution, B is what you're going to use.
We're actually working on instruction number 36. There's a picture on the bottom of page 12 that shows you exactly what's being done.
Yeah, like a table.
Right. Yeah.
Also it gives you like an estimate, like what would be the pH, right?
Right.
That's right. So we are now ready with it. So you can shake the well plate well. That's it. Catalase and the acid solution mixed well. Now we're gonna do the reaction. So let's see. Pick for each of the well 1 filter paper. Load it from the B1. I'm ready with my stopwatch. Push it down at the bottom and start.
The pH difference is huge. That's a huge effect on the rate.
So of course, as you can remember, you can wait for 3 minutes. If nothing is happening, that means the hydrogen peroxide is not breaking down, giving you oxygen. That should push up the filter disc to the top of the solution. You can stop right there. Let's discard this one. I don't know about your observations, so make sure to write down that. So let's keep doing this for different concentration of acid. So this is for B2. Let's load this. I'm ready with my stopwatch and let's start. make sure to write down your observation. Let me choose another one for B3. Load this. Push it down at the bottom. Start. Oh, okay.
And it reacted.
And it reacts. There you go. Let's do with B4. Vote.
So the results we're getting here can be used to determine the optimum pH in which the enzyme activity is observed.
Exactly. So I see some activity for B4. Make sure to record the time. Let's do this last one for B5. So let's get one, B5. Vote. Start. So, done for B5. We've seen the reaction happens. So, that's for variating the acid's concentration. That's how we get the changed pH, how that is affecting this reaction.
And so you would do the same thing for the base. And then when you're done, you pretty much make sure you fill the table. And like we showed you before, you don't have to actually repeat the experiment the second and the third time. If you do a good run the first time, you should be okay. So for all of this, you see the tables right here. I've crossed out trial 2, trial 3. You don't have to figure out the average time. The time you get initially is the time. Same thing for effective temperature, pH, with the acidic condition, and the pH with the basic condition. Because if you do it that way, it would take you a very long time. And we want you to be able to experience this lab because it is actually a very cool lab. It's a great experience. It's just that it's really long. And so we hope that this has been helpful.
Yes. So that's it.